What is up guys, welcome back to my YouTube channel. For today's video, I'm gonna teach you how to solve for the support reactions at A and B point. But before we continue this tutorial, if you are my new visitor, please subscribe to this channel and don't forget to hit the notification bell so you will be updated for more videos. And without further ado, let's resume this tutorial. As you can see, we have load here equal to 10 Newton per meter. It's already distributed from this point to this endpoint, which has a total distance of 7 meters. What we must do first for us to solve for support reactions is to get the summation of moment equal to 0 at any point, either at point A or point B. Any of these 2 points will give us a same result. But as you can see, I have chosen at A point. So summation of moment at A point equal to 0. Then I have assumed that any force has a clockwise direction must be positive. Since Bx is a horizontal force, so it has no perpendicular distance to point A. Therefore, the forces that we can only be considered are those vertical forces, which are By and the load weighing 10 Newton per meter. And we know that the pin support, there are two reactions here, the horizontal reactions and the vertical reactions, while in the roller support there is only a one reaction, which is the vertical reaction only. So we called it as AY. Then in pin support we called it as BY for vertical reaction and BX for horizontal reaction. First is By. As you can see, it has a counterclockwise direction, so it must be negative, times the perpendicular distance, which is 4 meter plus 5 meter. It is 9 meter. Second is the load weighing 10 Newton per meter, and it has a clockwise direction, so it must be positive. Since it is distributed already to its total distance, which is 7 meter, we can solve for its independent force by multiplying it by its total distance. So 10 Newton per meter times 7 meter. So we can cancel the meter, so we can get the independent force. Then we must multiply it by the total distance, or the perpendicular distance to point A, which is 4 meter, then plus the distance from this point to this point, since it is the location of the independent force. And it is 3.5, because the half of 7 meters rather, is 3.5 meters. Then equate 8 by 0. Then we can solve for the value of By through transpose this term to the other side of equation. So it would be negative 70 Newton times 7.5 meters rather. Then we can cancel the negative sign for both sides. So By equal to 70 Newton times 7.5 meters over 9 meters. So we can solve By. 70 times 7.5, over 9. So the value for By reaction is 58.3333 Newton. So correct. Then now we can solve for the reactions Ay by using summation of Fy equal to 0. Then let's assume that all upward forces must be positive. So vertical forces Ay, By, and the load weighing 10 Newton per meter, or the independent force. Okay. Ay, since Ay has an upward direction, so it must be positive. Ay. Then By, it has also an upward direction, so it must be positive. Then the independent force, it has a downward direction, so it must be negative. So negative 70 Newton. Then equate it by 0. So since we have the value for By already, which is 58.3333 Newton, we can solve for the value of Ay reactions. So 70 Newton minus 58.333 Newton is equal to 11 point, let's recheck, 70 minus 58.3333. So it's correct, 11.6667 Newton. Okay, now we can solve for Bx by using summation of Fx equal to 0. Then assume that all forces that is going to right path must be positive. So since there's no any direction or load that is designed to be in horizontal force, so we can say that Bx is equal to 0. So that's all for today's video. I hope you learned something crucial about this topic, and see you in our next video tutorial. Have a nice day. Thank you and goodbye. Peace out.